Okay, folks, so in order to start today's lecture, you guys are going to need a few things. The first thing you're going to need is your note packet, which for you is going to be blue, and then you're going to need a stoichiometry roadmap, which should be handed out to you. You're going to need 2 different colored writing utensils. So there's a bin of colored pencils. You guys should have gone and grabbed 2 colored pencils of different colors. And then you're also going to need a calculator, okay? So make sure you have all of those things before you continue. If you need to hit pause and go get anything you're missing, go do that now. So that way you'll have everything in hand when you're watching the video. Okay, so what we're going to do today is learn what some people call is the hardest part of chemistry. But honestly, if you pay close attention, this is something I like to call complicated but not difficult. So there's a lot of steps involved, but if you pay attention and follow the procedure, you guys should be okay. So the topic today is stoichiometry, okay? Before we dive too much into the note packet, I want to give you guys a brief idea of what stoichiometry means. We use stoichiometry to make predictions about products and reactants. So this is what I mean by that. Let's say that we're starting out with like 127 grams of hydrogen. We want to figure out from that 127 grams of hydrogen, how much water can we make? We can get that answer using stoichiometry. Okay? Also, if, for instance, we made 600 grams of water, we could look at that 600 grams of water and we can work backwards and we can figure out how much hydrogen and how much oxygen went into making that 600 grams of water. Okay? So this is a really useful skill for chemistry. You're going to use it for the rest of the year. So pay close attention today and it should make sense. Okay? So starting out with your note packet, stoichiometry is defined as the calculation of quantities of substances in reactions. Okay? It comes from the Greek word stoikon, meaning element, and metron, meaning measure. Okay? So really this is a way of measuring elements in reactions. Okay? Let's see. Chemical reactions or equations must be interpreted in terms of particles, or they can be interpreted in terms of moles. Moles, remember that was from the last unit, and that's going to come up a whole lot in this chapter as well. The law of conservation of mass states that mass is conserved in chemical reactions. So that means the number of grams of reactants must equal the number of grams of products in any given reaction, and that's going to be a really useful thing for us to be using. It's really why stoichiometry works. Okay? So stoichiometry works using the coefficients of reactants and products in mole ratios when we're doing stoichiometry calculations. So just to remind you guys what a coefficient is these big numbers out front. Okay, so this 2 is a coefficient, not the small 2, that's a subscript, but the big 2 here, and then this 2 here. And remember, if there's no coefficient written, that's an understood 1. Okay, so technically there's a 1 here, but we don't normally write 1s, because if we just write nothing, we're assumed it's a 1. Okay, so remember, blanks are 1s. Okay, so those are the coefficients I'm talking about. Before we go into doing the calculations, I want you guys to pull out your roadmap and start labeling these conversions with me, okay? So this roadmap is called a roadmap because it literally does exactly what a roadmap will tell you. If you know what your starting point and ending point is, roadmaps will tell you the path you have to take to get from your start to your end, and that's what this stoichiometry roadmap will do to you as well, okay? So we're always going to start with something and we're going to end with something, and depending on where you start, that's going to determine your ending as well, okay? Every single one of these arrows will represent a different type of conversion that you're going to have to do, okay? So as it turns out, we know a lot of these conversions already. So think to yourself really quick. If you want to go from particles, which again, a particle can be a molecule, an atom, or a formula unit, okay? If you want to go from particles into moles, what's the conversion? Do you know it? What do you think? Okay, so it's going to be, you're going to have mole on top, because we want to be left with moles, and you're going to have that number 6.022 times 10 to the 23rd on the bottom. Okay, so technically you're going to start with your number and divide by 6.022 times 10 to the 23rd, and that will get you into moles. Likewise, mass to moles. Do you remember the conversion for mass to moles? It was 1 mole divided by the molar mass of the compound. And remember, molar mass will always be in grams, and that's when you look at the periodic table and you add together all the parts. Like for CO2, you would take 1 C and 2 O's and add all the masses together. That would give you your molar mass. Okay, so divide by molar mass to get to moles. And lastly, volume. Do you remember the conversion to go from volume, which is liters, into moles? It was 1 mole divided by 22.4 liters. Okay, so these are all the conversions that we use to go from particles to moles, mass to moles, volume to moles. I'm going to skip this part for a second and go over here. Now, if we're starting in moles and going to particles, do you remember the conversion? It's going to be 1 mole on the bottom now, because we want moles and moles to cross out, and then we'll have 6.022 times 10 to the 23rd on top. Okay? Over here, moles to mass, we're going to do something similar to what we did previously, but now we're going to have 1 mole on the bottom, and we'll have molar mass on top. Okay, and then moles to volume, similar to over here again, but now we're going to have moles on the bottom, so that moles and moles cross out doing our conversion, and we're going to have 22.4 liters on top. Okay, so we already know all of these conversions. We've been using them for the last unit. Okay, so those should be pretty familiar to you. The only thing new that we're really talking about is going between different moles in the same reaction. Okay, this is what we call the mole ratio step. Okay, in this step with the mole ratio step, we use the coefficients in the equation. So I would write this down. Use coefficients from equation. People will often forget where we're getting these numbers from, and we're using the coefficients from the equation. So we're going to put the coefficient for whatever it is that we want on the top of this conversion, and the coefficient for whatever we have on the bottom. Okay, and I promise this will make sense in a second. Okay, so just copy that down and then switch back to your blue packet. Okay, so we're going to walk through how to do these problems. So putting this aside for a second, back to our packet. Let's read this first problem. So how many moles of NH3 are produced when 0.600 moles of N2 reacts? Okay, this is where you guys are going to take your 2 colors. I'm going to take my have color is my red, my want is my blue, okay? In this problem, what are we given to start with? What do we have to work with? It's this guy right here. We have this many moles of N2. That's what we have to work with, and I'm going to call that the A. Okay, that's what I'm starting with. That's A. I'm also going to find the coefficient. So I'm working with N2. So I'm going to look down at the reaction, and I'm going to underline the coefficient for N2. Okay, so N2 is what I'm starting with, so I underline that coefficient in the same color. So again, there's no coefficient there, so I'm assuming it's 1. Now I'm looking at what I want. What do I want to solve for in this problem? Looking at it again, it's asking how many moles of NH3. Okay, so that's what I want. Moles of NH3 is what I want. I'm going to label that B, and then I'm going to look at NH3 in my reaction, and I'm going to underline that coefficient as well. Okay, so now I've got my coefficients underlined that I'm going to be using. I know what I have. I know what I want. Now I can start looking at my roadmap. Okay, if you guys notice, we are in moles of N2, and we're trying to get to moles of NH3. So this is our A, that's our B. If you look at the roadmap, we have a bunch of different starting spots. We could have particles of A, mass of A, volume of A, or moles of A. Which one are we starting with? It's moles of A. Okay, so moles of A is where we're starting, okay, because it has moles of N2. And then we're turning into moles of B, particles of B, mass of B, or volume. What do you think? Look back at the problem. We're solving for moles of NH3. So this is where we're starting now, and then this is where we're ending. So knowing our starting and ending, this tells us that we only have one conversion to do, and it's this mole ratio step. Okay, so this is how we can apply that roadmap. So I'm going to write down what I started with. Okay, so 0.600 moles of N2 and start my conversion. And now, again, the conversion says want over have, and I'm going to use the coefficients from the equation. So I have N2, and the coefficient for N2 is 1. So I'm going to put 1 mole of N2 on the bottom. And then have was on top, and according to my equation, my have is 2. Okay, that's the B. The NH3, the coefficient was 2, so 2 moles of NH3. Okay, and again, I only have to do one conversion here, so that's going to be it. So in my calculator, I'm just going to go 0.6 times 2. Okay, so 0.6 times 2 is going to be 1.2, but in case you doubt me, here it is. 1.6 times 2 is going to be 1.2. Okay, so 1.2. Now you guys know that's not enough in my class. I need to have the units as well. So let's check out what units should be. I have moles of N2 and moles of N2 cross out, leaving us in moles of NH3. So this is going to be 0.12 moles of NH3. Okay? And that's our final answer. So this looks like a lot of complicated process, but the more you see it, the easier it's going to get, I promise. Okay, so to recap, we just identified what we have, what we want. We looked at the roadmap and figured out where we were starting. We were starting here, we were going there, and that told us that we were using one conversion, and then we looked at the coefficients for our things that go in the conversion, plugged them in, and did the math. Okay, I promise you it will get easier, it will go faster. This is the first one, and it's going to look a little overwhelming. Okay, so let's just look at the next one. Okay, so practice problem number 2. How many moles of Al are needed to form 3.7 moles of Al2O3? So what do we have to start with? What are they giving us to work with in this problem? It's 3.7 moles of Al2O3, so that becomes our A. Then we look back, okay, Al2O3, in the equation we have a coefficient of 2. Now we figure out what we want. What do we want? We want moles of Al. Okay, so moles of Al are here, and then we look at the coefficient in front of Al in the equation, and it's 4. Okay, so Al has 4, Al2O3 has 2, so we've found out our coefficients. We look back at a roadmap and figure out where we're starting. So moles of Al2O3 to moles of Al, that's going to be another moles to moles problem, okay, because we're starting and ending in moles. So the only conversion we have to do is this one right here, where we use the coefficients from the equation. So let's go ahead and set that up. We're starting out with 3.70 moles of Al2O3. That's what we're starting with. Here comes the ratio. Remember, it's want over have. So we have Al2O3, so that coefficient was 2. So 2 moles Al2O3. What we want goes on top. We want Al, and according to the equation, there is 4 moles of it. So 4 moles of Al go on top. Now, here's the deal. There's a number on top and on bottom, and what do we do at that point? Here it goes. It's really easy. In your calculator, what you're going to do is 3.7 times 4. Okay, see how it says times 4? So 3.7 times 4, hit equals, and then leaving that number in your calculators, now just hit divide by 2. And there's your answer. So it's going to be 7.4, and then checking the units, moles of Al2, moles of Al2O3 cross out, leaving us with moles of aluminum. So this is going to be moles of Al. And that's our answer. Okay? So again, what I just did was 3.7 times 4, got the answer, and then divided it by 2. And that's how I got there. Okay? So yeah, so that's the most basic version of stoichiometry. It does get a little bit more complicated. So here comes a little bit more complicated version, okay? Just as a heads up for these next ones, in order to relate the masses of reactants and products, they have to be converted to moles before we do any conversions using the mole ratio step. So that's what our next thing is going to explore. Okay, so this next sample problem we've got, let's see, calculate the number of grams of NH3 produced by the reaction of 5.4 grams of H2 with excess N2. Okay, before we go any further, excess N2 just means we have extra of it. It won't run out. Basically, it tells you ignore the N2. Okay, so what are we given to work with to start the problem? What is our given? It's 5.4 grams of H2. Okay, so that becomes our A. Then we look down at the equation and we underline the coefficient that's in front of the H2. So we've got that covered. And now we find what we want. What do we want to solve for? We want to solve for grams of NH3. So that becomes our B. And then NH3 is here, looking down at the reaction. Our coefficient is 2. Our coefficient in front of the NH3 is 2, so we underline the 2 here, and so now we've identified our coefficients that we'll be using. Okay, next step is to figure out where we're starting on our roadmap, okay? So remembering what we're starting with, we're in grams of H2 to start with here. So looking at our starting spot, are we particles, mass, volume, or moles of A? It's going to be mass, because mass is grams. Okay, so if we're starting in grams, this is going to become our starting spot. And then looking at our ending point, it's asking for grams of NH3. And so looking here, is that moles, particles, mass, or volume? It's going to be mass as well. Okay, so now we've identified our starting and our ending point. And look at how many arrows are between the starting and the ending point. We've got 1, 2, 3 arrows between the start and the end, which means we're going to do 3 different conversions. Okay, the cool part is, using this roadmap, we already know what the 3 conversions are going to be. Okay, they're already labeled. So let's go ahead and start. Writing down what we're starting with, we've got 5.4 grams of H2. And here comes our first conversion. Looking back at our roadmap, our first conversion is going to be 1 mole over the molar mass of A. Okay, so our A in this point is the H2, so we're going to have 1 mole of H2 over the molar mass of H2. And looking at the periodic table, 1 H is 1.00 grams, so 2 H's is going to be 2.016 grams of H2. Okay, so that's our first conversion, 1 mole over molar mass. Here comes our next conversion. So we just did that one. Here's our next one. Okay, that's going to be our mole ratio step, want over have, using the coefficients. So want over have. So we have this one. Our coefficient in the equation was 3. So have goes on the bottom, so 3 moles of H2 goes on the bottom. And then want goes on top. NH3 is what we want. The coefficient in front of it is 2. So 2 moles
Students and staff,
of NH3.
This was a false alarm. Once again, this was a false alarm. Thank you.
Okay, and that was our second conversion. On to our last conversion. Looking back at the roadmap, we did this one, we did this one. Our last one is here. So now we're going to have our molar mass on top over 1 mole, and that's the molar mass of B. Okay, so looking here, molar mass of B is the NH3. Okay, so we're going to have 1 mole of NH3 on the bottom. And then the molar mass of NH3 on top. And the molar mass of NH3 is, I believe, 17.304. I'm sorry, put 034 grams. Okay, and so now we've got our setup. Let's double check that all of our units cross out. We've got grams of H2 and grams of H2 cross out. Moles of H2 and moles of H2 cross out, moles of NH3 and moles of NH3 cross out, leaving us in grams, and that's going to be grams of NH3. So we know we set this up correctly because remember it's asking us for grams of NH3. So this is how we're going to do this in our calculator. This is kind of similar. I don't know if you guys remember doing dimensional analysis way back when at the start of the year, but we're going to put our starting number in our calculator, so 5.4. And our first thing to do is divide by 2.016. So divide by 2.016, hit enter in your calculator. Next thing you're going to do, leave that number in your calculator, and now we're going to multiply by 2 and then divide by 3. So multiply by 2, enter, divide by 3, enter. And then our last step is to multiply that answer by 17.034. So we're going to multiply by 17.034. And converting it to decimal, we get 30.4. And remember the units, it's going to be grams of NH3. Remember, guys, half of the points in your answer is the unit. It's not just enough to leave a number. You have to provide the unit as well. Okay? So that's the first grams to grams conversion that we're going to practice. We're going to do a couple more just to make sure you guys have this under your belt. So here is the next. Okay, how many grams of Mg are needed to produce 1.5 grams of MgCl2? So guys, what are we starting with? What are we given to work with here? It's going to be 1.5 grams of MgCl2, so that becomes our A. And then what do we want? What do we want here? We're looking for grams of Mg, so that becomes our B. Okay? Oh, and don't forget to underline your coefficients. So for our B, look down at the magnesium, and it's technically a coefficient of 1. Same thing for the MgCl2. Look at that, and it's a coefficient of 1 as well. Okay? So we've got all that identified. Let's look at our roadmap. Where should we be going here? So in this case, we're starting in grams of A. So remember, grams is going to be our mass. Okay, so this is our starting point. And then it's asking us for grams of B, which is also mass. So we're going to end here. So we're going to do the same series of conversions as the previous one. We're going to start here, end here, and we're going to do 3 conversions to get there. All right, so that's our setup. Okay, so write down what we're starting with. We've got 1.50 grams of MgCl2. Remember, the first conversion was to do 1 mole over molar mass. So we're going to do 1 mole of MgCl2. And then the molar mass, you guys would add 1 Mg plus 2 Cls, according to the periodic table, finding their masses. But I'll just give it to you. It's 95.2 grams. Okay, and that's MgCl2. On to our next conversion. Our next conversion, so we just did this one. Here's our next conversion. It's going to be the mole ratio step using the coefficients, want over have. So we have MgCl2, that's a coefficient of 1, so 1 mole MgCl2, and then we're going to have what we want on top, and that's a coefficient of 1 as well, so 1 mole of Mg on top. So that was our second conversion. And then to our last conversion, take a look back at your roadmap, and we've got, now we're in moles, and we're going, our last conversion, molar mass over 1 mole of B. In this case, our B is magnesium. So we're going to have 1 mole of Mg, and then the molar mass of magnesium is 24.3 grams. Okay, so doing all of this math out, what you would do in your calculator, you're going to go 1.5 divided by 95.2, get that answer and leave it in your calculator. The next step technically would be to multiply by 1 and then divide by 1, but that's not going to change my answer at all, so I'm going to skip it. And now I'm going to just multiply by 24.3. Get my answer, turn it into a decimal, and I get 0.383. But what are my units? Let's double check. I've got grams of MgCl cross out, moles of MgCl cross out, moles of magnesium cross out, so that tells me I'm in grams of magnesium. Okay, so there's that. Okay, so this is what I want you guys to do. Try the next 2 practice problems on your own, and then come back here and check and see if you guys did them correctly. Okay, so give that a shot. Okay, let's see how you did. So the first practice problem, we start with 3.2 grams of CaC2, and then we want grams of C2H2. We underline our coefficients for each one, so it's a 1 coefficient to 1 coefficient. And then we take a look at our roadmap. And again, this is going to be another mass to mass problem. So we're going to start in mass of A going to mass of B. So we're going to do 3 different calculations. Okay? So the first one, as usual, is going to be 1 mole over the molar mass. And so if you look, we're going to have 1 mole over molar mass. That's our first one. And again, it's going to be the molar mass of the first thing we're starting with. The next step was that mole ratio step using the coefficients in the equation, which was 1 to 1. We have want over have, so whatever we want goes on top, what we have on the bottom. And then our last conversion was molar mass over 1 mole of B, and again, this is our B compound. So adding together the mass of 1 mole here, and then 1 mole of B on the bottom. In your calculator, you went 3.2 divided by 64.1, technically times 1 divided by 1, and then times 26.036, and that gets you your answer here. Remember, did you check to make sure all of your units cross out? Moles of this, moles of that, moles of this, moles of that. Mine cross out. Do yours? Okay. I'm going to be really on everybody's case about labeling their units inside all of their conversions. If you had just put 1 and 64 and 1 and 1 and 26, that's not enough anymore. I let it slide last unit, but not anymore. So make sure you're labeling those things, otherwise you're going to lose points on quizzes. Okay? All right, so that's what the answer you should have gotten was. The next one was just the same idea. In this case, grams of A to grams of B. Here's our coefficient A, here's our coefficient of B. Our roadmap tells us to start with 1 mole over the molar mass of A, so here's our 1 mole over the molar mass of A. Next step was the mole ratio step, want over have. Here's our coefficient of what we want. Okay, we had 2 copper. Over what we have, we started with this, so 1 mole of that. And then our last step was to multiply by the molar mass of B over 1 mole of B. So here is our molar mass of B over 1 mole. And in our calculators, we're going to do 2.7 divided by 159.16 times 2 divided by 1 times 63.55. Okay? If we double check that all of our units cross out, which I believe they do, yep, we're going to end up in grams of copper, which is what they're asking us for. Okay? So that's how you do stoichiometry. We're going to go a little bit more into the nitty-gritty details next time I see you guys. But this should be a really good start. If you have any more questions, absolutely come see me. Okay? Good luck!